Hello everyone, this is the video for Faith for Algebra 1 and today's date is April 29th. So this is the lesson for, did I just totally get that wrong? Is it April 29th? Yes, yeah, sorry. It's April 29th. I forgot to write it on the board. So today's lesson is going to start on page 390. Not 390. Today's lesson is going to start on page 420. The reason why I had it turned to 390 is because actually we're doing a lesson opener that is kind of a review of some special patterns we had on page 390 that's from 9.5. This is going to, trust me, link into what you're doing today, which is special patterns. So let's look up here. What we learned in 9.5 is special products, and one of these products that we had was called basically difference of squares. And what we learned back in chapter 9 is if I've got difference of squares, when I'm putting them together, I don't have to use full and completely kill myself trying to figure out, oh, you know what? Difference of squares, what happens is my middle term is just going to cancel out each other because, you know, one's positive, one's negative. So what I see when I'm trying to square these together, I don't really have to worry about the difference of terms. And remember, this is the difference of squares. That means they're different. So that's how we're going to do these first three, 1, 2, and 3. I know my middle term, this should become a trinomial. That's what we learned. We multiply two binomials, it should become a trinomial, but a special pattern with multiplying the difference of squares is that it would automatically become, multiplying it together, as 2x squared and to a negative square, right? That's what it would, putting that together, it would automatically become that. Same thing down here. We would simply square the first term, square the last term, and since it's the difference of squares, it would be negative. That second term will be negative. So that would be a squared. I'm going to square this last term, and that's going to be a negative 16. I don't have to worry about the middle term because it's canceling itself out. You're going to have the same middle term except one's positive, one's negative, and it goes away. So I'm just going to do a little arrow. Same thing here. We're going to multiply these together. It will become a 4x squared. We're going to have, go ahead and multiply these two together, and it will become 9y squared. So that was one pattern we learned back in 9.5. That was called the difference of squares, where I really don't have to worry about trying to do the full method all the way through because that was a pattern that just happened in math that God gave to us to cancel out that middle term. Then we learned another pattern, and that pattern was to do with perfect squares. That's where you're taking a binomial and you're squaring them together. And if you looked all the way back like we did in 9.5, normally what would happen is you would take the product of this, and I would automatically know what my middle term would be because I would, the product of those two numbers would be doubled in the middle. So, for instance, if I'm squaring, my squaring this, it would end up being a 25x squared, right? Then, if you can remember what it looked like and what it kind of looks like in your book, that middle term would become twice the product of A and B. Twice that product. I don't really want to confuse you too much. So, what is the product of 5 times a negative 2? Oh, that's a 10. I'm supposed to double that because it's a perfect square. So that's going to become a negative 20x, right? And then my last product is I'm going to take the negative 2, multiply it by negative 2, right? Square it, or I'm going to square it, and that's a positive 4. So that's what I would end up with a perfect square. And if we learned in 9.5, if this is negative, my middle term has to be negative. Then we have a perfect square where it's positive all the way through. What do you think is going to happen to your middle term now? Oh, it'll be positive. It won't be negative. We simply square it. I'm going to have 9x squared is the first one. I'm going to multiply my product, or my A and B. That's going to basically end up being if we look at it, that's going to be a 15. Then I double it. That's going to be 30. Now, what am I going to do with those two variables there? Well, they just come along with the ride. You're going to have xz in the middle. They go with it. That's fine. Final one is I'm going to square that last one, so that will become 25z squared. So right now, hopefully you did not fast forward this, because this is leading in to exactly what we're doing today, and that's special patterns. We learned those special patterns in 9.5 to be able to figure out how to multiply those together and not have to go through the full method, but just recognize that pattern. Well, guess what? These top were difference of squares. These in the bottom were perfect squares. Guess what your special patterns are today? The same thing. You can take that same concept, and if I have a trinomial, I could go ahead and make them into binomials. So if I see a pattern that's right here, that's a squared minus b squared, that's automatically telling me that is a difference of squares. My two binomials, if I factored them, would look like that. Then I had perfect squares. Remember, that's what we did over there, and we multiplied it to make it look like this over here. That's the same pattern. So that's the same pattern, except if I'm factoring, I would take this trinomial and I would make it into this binomial squared. This trinomial and make it into, the only difference, if this middle term is negative, that's going to make this one negative. How can that help me? If you can learn this part of it, then suddenly you don't have to figure out that all these weird factoring methods, for like the British factoring method like we were doing yesterday. This is a quickie, easy peasy method if you learn it. Some of you chose not to learn it in 9.5. Math always gives you another opportunity. 10.4, you can now learn that special pattern. Here is a pro tip, as you want to call it. I saw YouTubers who did that once before. If you can learn difference of squares, if you can learn perfect squares, those are guaranteed to be on any type of standardized test, including the ACT that might be coming up for some of you guys. If you recognize it, you don't even have to use your calculator. You can automatically figure it out and automatically do it. So, they've given you several examples that you could do. I have highlighted, example 1 is, you got one that looks just like that on your quiz and test. So make sure you learn factoring the difference of squares. Make sure you learn this factoring the difference of perfect squares. That's both on quizzes and test. One thing that people tend to not do before they do this pattern is, it's technically not wrong, but it's just not right either, is you may not factor out a common monomial. That should always be your first step, is going all the way through and saying, is there something common to all of my trinomial that I could potentially factor out? Is there a common monomial? And quite often we forget that step. You end up with two binomials that have something in common that you need to factor out. So if I was doing this homework lesson, I would suggest doing 1 through 33 odd to make sure you're getting it. I'm going to tell you on this entire page of homework that you're doing, one of them's prime if you're doing the odds, or you're doing the evens. One of them's prime. So don't think, okay, can't get this one, guaranteed it's going to be prime. Your quiz that's over this, none of them are prime. Your test that's over this, the entire test, one of the things you're factoring is prime. So don't make that your standard answer. Oh, it's prime, prime. Don't sound like one of those seagulls. We are going to do a few of these just to see if you can get them rather than trying to go through all the examples, because this is a pattern. This is something you should probably be able to put into practice fairly easily. 1 through 6 is just seeing if you can pick out what the numbers are. If you go through 7 through 12, they're asking you questions. Is it a perfect square? Say yes or no. If it is a perfect square, say why it's a perfect square. Why would it be a perfect square? It's because the middle term is doubled, right? That would be your justification for why it's a perfect square as I'm going through this. I'm going to start with 13. So I'm looking for 13. And I'm going to do these over here. So that way we can kind of look back over here and say, okay, which one is it? I'm going to erase that. I don't know why. Those arrows are just bothering me. So let's look at 13. So 13 looks like this. I have a square, and that is a negative 225b squared. All right, guys, we've got them right up here. Of the two patterns that we've looked at, what would this look like? Would it look like a difference of squares, or would it look like a perfect square? Well, there's an obvious difference between the difference of squares and the perfect squares. Perfect squares are trinomials, where a difference of squares would end up becoming a binomial. This is a two terms binomial. Wonder which one this is. Oh, right, difference of squares. So this is what I'm looking for. So what am I going to do? I'm going to take the square of these. Yeah, it's a big square, but you've got a button on your calculator that says square, and you should be able to figure that out. This is one, probably 7th and 8th grade, you are technically supposed to remember it all the way up to. It's one that sticks in my head. If it's stuck in my head, it probably is lodged in yours somewhere. So I'm going to come up with two binomials from this one. So what would be the square of a square? Oh, how about a? That's difference of squares, which means one of these has to be plus, one of those has to be negative. What is the square of 225? That is one that you probably had to memorize back in 7th, 8th, 6th, something. That's 15, all right? So 15 times 15 is 225, right? Right. All right, so 15. You still have a variable up here. What is the square of b, or what is the root of b squared? That would be b. So let's compare. Difference of squares. I took the square root of a, I took the square root of b, and I put them into two binomials. That's exactly what we did here. We took the square root of each of those and put them into two binomials. You can check yourself by using the full method or by going back to what our pattern was for our special pattern or our special product of difference of squares, and you would end up with that. Now I want to bring you down to 17. Let's look at 17. So 17 is x squared minus, I keep flipping back and forth, x squared minus 16x plus 64. So let's look at our special patterns. Special patterns, is it a difference of square, or would this one be a perfect square? Well, difference of squares would end up becoming a binomial, so this one is a 1, 2, 3, 3 terms. That's a trinomial. It looks more like a perfect square. I don't necessarily have to be in the screen. You can just see my hand floating around. And if that middle term is negative, then that's telling me, that means whatever I get when I get my perfect square, that second term needs to be negative. So we know that part. This is going to be a perfect square. That middle one is going to be negative. You got that far. Just looking at patterns, you've gotten that far. Now, what would be the square root of x squared? Oh, that is just going to be an x. There's two ways. If it's a perfect square, there's two ways, and this might be a good way for you just to check yourself to see if it would happen. Let's say you're a clueless and you don't know what the square root of 64 is. Clueless. But you do know enough about perfect squares to know that that's basically the product of A and B doubled, which means that is a 1, right? And, that would be like a 64, right? That would be A and B, and that would be doubled. You could always, if there's everything, the only thing here is a 1, you could always just half that middle one. But that's a pretty easy square root. If you all got 225, then you could probably get that other one. So that's just going to be 8. See? That's done. Not as much factoring as you did yesterday when you thought you were going to panic and die. Let's move on down to 21, and that's the only one I'm going to do for the day, or that I'm done for the day after this. Eventually I'll get to this. So this will be a kind of short lesson, but like I said, this is a special pattern. It's not that, you're basically just looking at stuff and sticking it into this pattern. Does it fit there? Does it not? So, and that's something else for you to consider, is if it doesn't fit one of these special patterns, if you've got everything here and it's not fitting it, chances are it might be prime, right? If it doesn't if it doesn't fit the special pattern, then that's a good clue that it might be prime. So 21 looks like this. I have 2a squared and a negative 242. Right off the bat, you start saying to yourself, it's a binomial. It's probably going to be difference of squares, right? And that's negative. But do you remember what your first step was to factor a trinomial, binomial, whatever? The first step is to factor out a common monomial. The first step is to factor out a common monomial. I don't know how many times I've said this. That is a question, verbatim question on a quiz. What's the first step to do in factoring? Factor the common binomial. So what's a common monomial from this? They're both even numbers. Now you can understand why you had to figure out all these weird divisibility rules ever so often. Those are both even numbers. So if nothing else, if I'm completely clueless, then, and I go with my smallest prime, 2 is common between both of those numbers. So I'm going to factor out 2. I have 2. I'm going to divide 2a squared by 2. Now I'll just have the a squared. I'm going to divide 242 by 2. So I'm going to divide 242 by 2. And what do I get? 242 by 2 would be 121, which hopefully that's saying, ooh, I think that's one of my perfect squares that I memorized when I was in the 6th grade. Hopefully, right? So I've factored out the 2. Remember, now that you've factored out your common monomial, don't leave him behind. He's lonely. Make sure you bring him down. That's looking really close, like my perfect square. So I know one's going to be plus, one's going to be minus. What would a squared be? The roots of a squared would be a. And then what is the perfect square? Or that is a perfect square. What's the square root of that perfect square, 121? That would be 11. So the main reason I did 120, or the main reason why I did 21 is so you would remember to factor out, that's the first step, is factor out the common monomial. Factor that out first. Then, once you get to that, you will have your perfect square. Because once you start, if you did try to factor that out, if you didn't try to factor out the 2 first, you might think, I've got one of those icky prime ones. What am I supposed to do? And it's not prime. You have to factor out, first of all, that common monomial, and then you can get it. So continue to practice this. There are no word problems on this quiz, therefore I'm not going over the word problem for this one. You do have a quiz just on 10.5. So let me look. Sorry. Should have had this one with me, but I didn't. So as I'm looking over your quizzes, this completes all the lessons for 10.3 and for 9.5, right? For 9.5. Now I'm on 10. I was looking at it and then I quit. So this is 10.4. This has completed the lessons for 10.3, and for 10.4 you have a quiz just over 10.3 and 10.4. Half of it's 10.3, half of it's 10.4. One of them's a really easy verbatim question. What's the first step in factoring a polynomial? Factor out the common monomial. That's the real easy one. Tomorrow we'll complete 10.5. You have a quiz just over 10.5. So you only have one quiz over 10.5. Make sure you figure that out. So this is the way the rest of this week is going to work. Then we'll pray to close this lesson. We are going to cover 10.5. I'm going to do a review day where we go over each one of your test questions and I tell you what section it's from since it's open book. And then I'm going to look at your review. There's a couple of review problems that's in your chapter review that's very similar to a test question. So I want to make sure we do those in our review day just to make sure you know how to do them. And then next week, when you come on May 4th, you will pick up a chapter 10 test. Now, you'll have a few days to do chapter 10. And then what's going to happen is we're going to begin chapter 11. We do not have enough time to do a test on chapter 11. We will be able to get through most of the sections in chapter 11 because it's over radicals, exponents, square roots, those type of things. So we'll be able to do a lot of quizzes on chapter 11. And I think it's very important for guys going into your next math for you to figure out chapter 11 and for us to work on it, but you're not going to be able to have another test. So chapter 10 is your final test for the year, and tests are weighted more heavily than quizzes. So that's the end of this section for today. Let's go ahead and go to the Lord in prayer. Heavenly Father, we just praise you and thank you for giving us patterns where we can try to understand your creation and where we can understand more about ourselves. And Father, just be with our world. We are a dark and sinful world, and we're dying with disease and destruction, but we know that you can make all things new. We love you in Jesus' name. Amen. So have a great rest of the day. Hopefully, make sure you're getting some sunshine. See you later.